So the type of problem that we'll see a lot here looks like this. I just wrote this problem like this because the textbook tends to write the problems like this. So we have the limit as n approaches infinity of a sub n, and then we've got this series that's listed 9/5, 16/4, 65 over 27, ... 7n squared plus 2 over 2n squared plus 3n. So really, this is just our formula that gives us these numbers. So if we plug 1 into this formula, 7 times 1 squared plus 2 would be 7 plus 2, which would be 9. And 2 times 1 squared plus 3 times 1 would be 2 plus 3, which would give us 5. So this is the formula that tells us how to get these numbers. So we are wanting to do the limit as n approaches infinity, basically, of this formula. So we would have limit as n approaches infinity of 7n squared plus 2 over 2n squared plus 3n. So whenever we're trying to take a limit like this, it's not as easy to just think about what numbers we would plug in. It would be very difficult, actually, to plug all of these numbers in because it would take a lot of work. But there is a way that we can look at these using the properties of limits that will make it much more easy to figure this out. So the first thing we are going to do to solve these limits is we are going to divide each term by the highest degree term in the denominator. So what that will look like for this problem is we will say the highest degree term in the denominator is this 2n squared. So we're going to divide everything by n squared. So we will say the limit as n approaches infinity of 7n squared divided by n squared plus 2 divided by n squared over 2n squared divided by n squared plus 3n divided by n squared. So this looks like it actually made it worse rather than better, but if we simplify and then look at our properties, we'll see that it is actually going to help us come to the answer. So for number 2, or step 2, we are going to simplify. So we will say the limit as n approaches infinity of the n squareds will cancel right here. So we'll just have 7 plus 2 over n squared over the n squareds will cancel here. So we'll have 2. And then we'll have one of these n's will cancel in this term 3n over n squared. So this n will cancel with one of the n's here. So that will give us 3 over n. So what we can do at this point is we can use the property of properties of limits to find the limit of each term. So this next step that I'm going to write, I'm only writing for notes. I never write this when I actually work out the problem, but I just want to demonstrate how the properties apply here. So we can take the limit of things that are added together. We can take those limits separately. We can also take the limit of things that are divided separately. So what that's going to look like is we can take the limit of n as n approaches infinity of 7, and then we can add the limit as n approaches infinity of 2 over n squared, and then we can have the limit as n approaches infinity of 2, and the limit as n approaches infinity of 3 over n. So 7 is a constant. The limit of any constant is itself. So the limit as n approaches infinity of 7 is 7. The limit as n approaches infinity of 2 over n squared is going to be 0 because you have that n squared in the denominator. As those numbers increase, that denominator will get larger and larger and larger, causing 2 over n squared to approach 0. In the denominator, the limit as n approaches infinity of 2 is 2. And then the limit as n approaches infinity of 3n would be 0. So what we end up with here is 7 over 2, and that is our answer. So to think about what that means, if we pull up our calculator here, if I were to type in this formula in my y equals, I would have 7x squared plus 2 divided by 2x squared plus 3x. And if we were to go to look at the table, let's go back to our table step. Let's have this start back at 0. Let's actually have it go up by 100. We go to our table. We can see that these values are increasing, but they seem to level out around 3.5. We can get these values. They're increasing, but they don't look like they're ever going to actually make it past 3.5, and they don't. So that kind of shows us what we're looking at here. So let's do another problem like this. We've got the limit as x approaches infinity of x minus 3x squared over 4x squared plus 3. So we're going to do the same thing here. We're going to say this is the limit as x approaches infinity of, we need to divide by x squared here, so x divided by x squared minus 3x squared over x squared divided by 4x squared over x squared plus 3 over x squared. So let's go ahead and simplify here. One of these x's will cancel with one in the denominator. X squareds will cancel here. X squareds will cancel here. And then nothing will cancel in that last term. So if we, now I'm going to sort of shortcut this. I'm not going to take the limits, show that limit notation like I did on the last one. I'm doing the limit as x approaches infinity of, I've got 1 over x minus 3 over 4 plus 3 over x squared. So whenever I take this limit, the limit as x approaches infinity of 1 over x is 0. Limit as x approaches infinity of negative 3 is negative 3. The limit as x approaches infinity of 4 is 4. And the limit as x approaches infinity of 3 over x squared is 0. So I end up with negative 3 over 4 here. So my limit as x approaches infinity of x minus 3x squared over 4x squared plus 3 equals negative 3/4. Our next example here is a little bit different because they don't give us a formula. You have to come up with your own formula for this. So our a sub n here would be n over n squared. You can see that we have 2. We've got 2 over 2 squared is 4. Here we got 3 over 3 squared is 3. 4 is 4 over 4 squared, which is 16. You'll also notice that this will reduce to just be 1 over n. So we are really looking for the limit as n approaches infinity of 1 over n. And whenever we do that, that is going to be 0 because as that denominator gets larger and larger and larger, the value will approach 0. Okay. For our next example here, we've got the limit as n approaches infinity of 3 plus 4n minus n squared all over 2n. So we can work this problem out a couple different ways, but I'm going to do this. This is the way we've done the other problems. So the highest exponent in the denominator is n. Just n to the first power. So I'm going to divide everything by n. So I'm going to have limit as n approaches infinity of 3 over n plus 4n over n minus n squared over n all over 2n over n. And if I simplify that, I have 3 over n plus 4 minus n all over 2. So now I have to take the limit of each piece. So the limit as n approaches infinity of 3 over n is 0. The limit as n approaches infinity of 4 is 4. And then the limit as n approaches infinity of n is going to be infinity. Because that number will continue to get larger and larger and larger. The limit as n approaches infinity of 2 is 2. So we're given this. Of course, 0 plus 4 is just 4. So we've got 4 minus infinity divided by 2. Now, 4 is a very insignificant number when it's compared to infinity. So if we have 4 and we subtract infinity from it, we will get negative infinity. And then we have negative infinity divided by 2. But infinity is such a vast number, or idea of a number, that dividing by 2 does not even change the fact that it's infinity. So whenever we have infinity divided by negative infinity divided by 2, we will get negative infinity. So this limit approaches negative infinity, meaning as the numbers get large, as the n values get larger and larger and larger and larger, the value of that function is going to get lower and lower and lower and lower.